Hi everyone. So today we are here to discuss what is encapsulation when it comes to C++. Here we are going to discuss the basic concepts about encapsulation and why it is important. Starting with what is encapsulation. Let's say I have a class which has two data members and has three functions that are working on those data members. Now what happens is we create a class wherein we have two data members and three member functions. Now what happens is we have combined these two or we have bundled these two. Now the process of bundling these data with the methods is called encapsulation. Data and methods in one single unit. Now why do we need encapsulation? First thing, it protects the integrity of data. Now what do we mean by that? Let's say I have some data and anybody comes and makes changes in that data, then the integrity of that data is not protected. Now what happens with encapsulation, we have bundled our data with the functions and only those functions can work on that data. Nobody else from the outer world or outside of that class can access that data directly. So in this way we can protect the integrity of data. Also in this way we can have a controlled way of accessing and modifying the data. What do I mean by that? Let's say I have some data and somebody wants to make changes to it. Now, since I have bundled my data with methods and only methods can be accessed outside your class boundary, so anybody who wants to make any change in that data will go through the functions, and these functions are defined by us. So the changes that are made on that data are actually the algorithm or any function which we have provided to the outer world. Nobody can come and say, okay, you have this variable int a and I want to change it to 100. Nobody can do that. Only if I have a function wherein I can increment the value of that variable, only that function can be called from outside, and in that way only the modification can be done. Now let's discuss key concepts of encapsulation. The first thing is classes and objects. Now many people confuse between classes and objects. Let's dive more into it. Class. A class is a user defined data type. Like we have some primitive data type like int, string, boolean and more. So what do they define? They define what type of data they are going to store. Similarly, if a user wants a data type wherein he can store some integers, strings and boolean together, so he will create a class for that and will define, okay, this class is going to contain an integer, a string and a boolean. Now one more thing that he will do is he will also define the methods or the functions that are going to work on those variables. Now this is our blueprint, like it's just how it is going to happen. Okay, these are going to be your variables, these are going to be your functions. This is just a skeleton. Now what happens with an object is an instance of a class. Now you have defined, okay, whenever I declare a variable of this class, one integer, one boolean and one string is going to be instantiated. Now when you create an object for that class, let's say you had a class test. Now you say test A or test object. Now what happens when you say test A or test object? Your compiler will allocate some memory to that object. So that is an instance of a class wherein you have created some memory for that object, and here actually the values of your integer, your boolean and string would be stored. So class is just a skeleton, but an object or instance of that class is called an object. Now one more thing that is very important with encapsulation is access modifiers. Now when you say that you had created a class, you have some variables and you have some functions, and you don't want anybody else from outside the class to access your data members, then what happens is you make them private or you make them protected. Similarly, we have three access modifiers. Or when you say I have these functions that I want others to use, then you say these are public. Now we have three type of access modifiers. One is your public. Herein you define all the members, whether it be your data variables or your functions, that are to be accessed from outside the class. Okay, so here is whatever variable or whatever function you want others to call for your class, that are defined as public. Now the second is your private variables or private members. These are something that you don't want anybody outside your class to access to it directly. So you define them as private. Other people can access these variables or these members through your public members. So the private and the public is the most important things of your encapsulation. You tell your compiler that these are your members that you don't want anybody outside your class to access. So you say these are your private members. Now, when you have created a class, you want somebody to access something out of your class, right? So for that reason, you say, okay, these are my public members. These can be accessed from outside the class. In this way, you give access to others or you prohibit the access to some members by creating private members or public members. Now we also have a third type of access modifier that is known as protected modifier. Now what happens in protected is it is very similar to private. Whatever you declare as protected, nobody has the direct access to it. But when you say that you have some variables or some members as protected, these members can be accessed from your derived class. When you are working with inheritance, you want some members of your class to be accessed from your derived class as well. For those members, you can define them as protected. Now, when we have discussed about what is class, object, and your access modifier, the other thing that comes up is your data hiding. Now, what is data hiding? When we say that we have some members as private or protected and some members as public, what we actually are doing is we are hiding some of the members from the outside. We don't want anybody else from outside our class to access those variables or those members directly. And this is what is called data hiding. We don't want anybody to directly have access to those members, and they can only interact with these members through your public methods. This is an example of your encapsulation. Here you can see we have some private members and we have some public members. Now our data members are generally your private members because we don't want anybody outside our class to have direct access to our data members. So we say we have a double variable that is balance and we don't want anybody outside our class to have direct access to it. Now since we have some variable, we need some functions through which these variables can be accessed or these variables can be changed. So what we have is we have two member functions. These are deposit and get balance. Now what happens inside deposit is you can change the value of your balance, and for get balance you can access what is the actual value right now in your balance. And this way you combine or you bundle your data with your member functions and you create a class. Now when I say this class, this is just a blueprint that okay, when I'm going to create an object of this class, a memory would be assigned for balance and these functions would be there in your memory. But till no object is assigned for this, no object is created for this class bank account, your memory won't be assigned. In this way, class is a blueprint, but when you say bank account X, then your X would be your instance. This is more detail of the bank account class. Herein you see I have also given body to my functions. Here if you see, for get balance I return what is my balance, and for deposit whatever amount I have, if that is greater than 0 I add it to my balance. Now since I add it, I have to initialize my balance, so here I initialize my balance. In this way you can create your own classes. What is the benefit of encapsulation? We have discussed that when we encapsulate our data with functions that are going to work on that data, we are going to protect our data from outside access. In that way, if there is somebody who accessed my data directly and makes some changes, I won't be able to restrict that if I don't have encapsulation. But with encapsulation, I can protect my data and I can restrict the access to it. I can restrict how it is going to be used by others, right? Also, one very important benefit of encapsulation is your code maintainability. Now, when we are designing huge application, now when we split those big functionality into small pieces and we make classes for each thing, in that way smaller pieces are very easy to maintain. Now what happens is, when you have a change in one class, that is not going to affect your other class. Let's say in my program I have 10 classes and 4 of them are changing, but I don't have to worry about this remaining 6 classes. So I have to just focus on those 4 which are getting changed, not the other 6. But if I had a huge program, I have to be very careful with everything. But when I split my big program into smaller chunks, into smaller classes, each classes is independent of the other. So if one class is getting any changes, the other classes do not have to worry. Also, in this way, when we create a class, we just give an interface to the user, whether it be other class or any other function. We give the function, member function, to the other people to use, and these member functions works as an interface to your class. Anybody else doesn't have access to all the private members, so only the public members, which works as your interfaces, are directly accessed by your users. The other benefit of is your modularity. Now when you say, instead of one big class I have multiple independent classes, so it's easy to change any class and it's easy to manage. Also, when you're working on smaller chunks, it's easy to test and debug. So when you have smaller modules, these are very easy to manage. And also, I have already told you that internal implementation can be changed without having to change anything else apart from that class. So in this way, your flexibility also gets improved. To give you an example of how your encapsulation work in your real life, let's take an example of a capsule of medicine. When you take a capsule, you see an outer layer. Now your outer layer of your medicine is your interface or the functions, public members of your class. So you can take it, you can do anything with it, you can open it. The medicine that is there inside that capsule is your private data. You don't have to know what is there inside your capsule. You just know what is your capsule, how to take it. You have some prescription and you take it accordingly. But what is there inside the capsule? There can be many chemicals which you don't need to know, and that is how internally your encapsulation work. Your medicine inside your capsule is your private data, and the outer layer is your interface or public member. In this way, you can compare your encapsulation to any other thing apart from medicine. Also, you can take an example of your car, wherein you don't know internally how things are working. You just have a gear, you have a brake and accelerator, you know how to use them. But what happens inside, you are not worried about it, and that is also hidden from you. Encapsulation also provides data hiding. So you hide all the internal details. Like in medicine case, you hide the medicine, what chemicals are being used, you just hide it. Similarly, in car, you hide how internally it is working. Or you can take any example, whether it be your air conditioner, refrigerator, or anything. You can compare anything with encapsulation, how everything works around you. In this way, you can understand encapsulation better. Now, many people confuse encapsulation and inheritance. Encapsulation actually focuses on protecting your data and providing your controlled access to your data. Or you can say it focuses on your data hiding and abstraction. You abstract everything what is there inside your class, and you just give some public members as an interface for others outside your class. But in inheritance, you inherit the properties of your base class into another class or your derived class. Encapsulation focus on data hiding, but inheritance focuses on your data or your code reusability. You create some class, you reuse those code in your derived class. So you have some relationship between classes, but there is no relationship when you are talking about encapsulation. It's just one class and it is very closely bound. But inheritance is like multiple classes which are very loosely coupled. Encapsulation is very tightly coupled, while inheritance focuses on loose coupling, but encapsulation focuses on tight coupling. You tightly couple your data with your functions. Now, why both are important? Inheritance focuses on building, it's like building a building on already present blocks. Like you had some blocks, you want to use them to build a building. So that is inheritance. But encapsulation is like building your block. That's it for encapsulation. If you have anything, you can comment down and I'll try to answer everything. Thank you.